Jai Hind students, welcome to my YouTube channel. Students, the difference between ordinary and extraordinary is that little extra. So what I mean to say is that in order to be an extraordinary individual, you need to do those extra things. You need to do extra hard work. You need to show that extra dedication. You need to show that extra devotion, extra commitment. And that is when you will achieve things which are extraordinary. So students, with that, let's begin today's session. In the previous lecture, we have discussed about circular motion and the terms associated with it. We have discussed angular displacement, angular velocity, the relationship between angular displacement and linear displacement, then angular velocity and linear velocity. In this session, we will discuss about angular acceleration. Then we will discuss the relationship between angular acceleration and linear acceleration. And then we will also discuss about radial, which is the centripetal acceleration, and tangential acceleration. Right, students? So let's begin with angular acceleration. So, we'll first discuss average angular acceleration. Students, it is defined as the ratio of the change in the angular velocity to the time during which that change in the angular velocity has taken place. So, it is change in angular velocity divided by the time interval during that which the change in the angular velocity has taken place, right? So suppose at time t, angular velocity is omega, while at time t plus del t, the angular velocity is omega plus del omega. Then mathematically, average angular acceleration will be given by, this is the change in the angular velocity. This is the final angular velocity at time t plus del t, and this is the initial angular velocity at time t. So the ratio of these two is known as the average angular velocity. So it will be given by del omega divided by del t. This is average angular velocity, right? Now students, in the limiting case, what we do is, we consider del t to be approaching to 0, right? Del t approaches to 0. In such a case, what we do is, it will become from average angular acceleration to instantaneous angular acceleration. So, instantaneous angular acceleration would be given by, it is represented by alpha. So it will be given by limit del t approaches to 0, del omega divided by del t. And students, you are aware, this in calculus is actually the differentiation of angular velocity with respect to time, right? So angular acceleration is the time rate change in the angular velocity of the body. So this is the result. You can further represent angular acceleration in terms of angular displacement as well. Now, as we are aware, angular velocity in calculus is given by d theta by dt. Therefore, alpha, it may be written as d by dt. In place of omega, I can write d theta by dt. So, it is the double differentiation of angular displacement with respect to time. This is the symbol for double differentiation. So students, angular acceleration, it is either defined as the differential coefficient of the angular velocity with respect to time, or it is defined as the double differentiation of angular displacement with respect to time, right? Now regarding its SI unit. SI unit of angular velocity is radian per second. divided by time is second. So SI unit would be radian per square second. This is the SI unit of angular acceleration. So friends, I hope you have understood this concept, right? Now what we do is, we will try to represent alpha and try to find out its direction as well. As I stated, students, angular displacement, when it is infinitesimally small, angular velocity, these all are axial vectors acting along the axis, either upward or downward, depending whether the body is moving in the anti-clockwise direction or in the clockwise direction. So angular acceleration, this is also an axial vector. So its direction would be same as that of angular velocity. And angular velocity, its direction is same as that of angular displacement. Clear, students? So let me repeat that. Case 1. In case body is moving in the anti-clockwise direction, then the infinitely small angular displacement, the angular velocity or angular acceleration, all are directed along the axis and in the upward direction, right? In case the body is moving in the clockwise direction, it is moving in the clockwise direction, then the infinitesimally small angular displacement or angular velocity or angular acceleration, these all are axial vectors. They all will again act along the axis. This is the axis, but in this case perpendicular to the plane and in the downward direction. Clear, students? So alpha, angular velocity, infinitely small angular displacement, all are in the same direction. Right? Okay. Let's now try to find out the relationship between alpha and phi. So we are over with angular acceleration. Now let's discuss the second topic. That is the relationship between alpha. Alpha is the angular acceleration and A, which is the linear acceleration. For this, students, we will make use of the previous obtained result. We are already aware of the relationship between the linear velocity and the angular velocity, right? Let's make use of that particular relationship. So we know that in vector form, linear velocity, it is given by omega vector cross r vector. We are aware of it, right? So this is the cross product or the vector product. So what we do is differentiating both the sides with respect to time. Differentiating both sides with respect to time, we get dv vector by dt is equal to d by dt. This is a single term basically. This is the cross product of angular velocity and the radius vector. Now students, be aware of this particular formula. D by dx of a vector cross b vector. This is the symbol of cross product. It is actually a vector cross dv by dx. This is the first term plus dA vector by dx cross b vector. Right? Let's make use of this particular formula. This is the cross product. So it is expanded in this particular manner. So dv vector by dt, it will give us, I'm making use of that expression, so it will give us omega vector cross dr by dt. This is the first term, plus second term would be d omega vector by dt cross r vector. This is the second term, right? Okay, students. Now dv vector by dt vector, that is linear acceleration. Linear acceleration is the time rate change in the velocity of the body, which is given by the differential coefficient of velocity with respect to time. So this is the net acceleration. This is the net acceleration. This term, students, will discuss. It is known as the radial acceleration. And radial acceleration is also known as the centripetal acceleration. Why it is known as radial acceleration? Because it always acts along the radius towards the center of the circular path which the body follows, right? This we'll be discussing. So this is actually the radial acceleration. And this term, students, this term will come into play only when the body is moving with varying angular velocity. If it is uniform angular velocity, then this term gets eliminated because the differentiation of constant is 0. So this term will come into action only in the case of non-uniform circular motion, where the body executes the circular path with varying, changing angular velocity, right? So this is known as the tangential acceleration. So here I am writing first the radial or centripetal acceleration is AR vector, and it is equal to the first term. This is the first term. While second is the tangential acceleration. As the term suggests, it will act along tangent. It will be represented by AT vector. It is equal to d omega vector divided by dt cross r vector, which in turn is equal to, this is the angular acceleration cross r vector. And here radial or centripetal acceleration is omega vector cross dr by dt. It is the velocity vector, linear velocity vector. Clear, students? Therefore, net acceleration, it is equal to, this may be written as omega vector cross v vector. This, as I have told you, is the radial acceleration plus the second term d omega by dt, that's angular acceleration cross r vector. This is the tangential acceleration. So net acceleration is the vector sum of the radial acceleration and the tangential acceleration. Now we will discuss these two terms in detail, right? Okay, let's consider first the tangential acceleration. Look, students, the second term is the tangential acceleration, this one. Second term, that is tangential acceleration is alpha vector cross r vector. Now in case of uniform circular motion, that is when the body executes the circular motion with constant angular speed. In such a case, differentiation of constant is 0. Therefore, tangential acceleration, it is d omega vector by dt cross r vector. So it will be equal to null vector. Clear, students? So that's a very, very important concept. In case the body possesses uniform circular motion, then it will only have one type of acceleration, and that is the radial or the centripetal acceleration. And students, remember, this radial or centripetal acceleration only makes the body to change its direction of motion continuously without changing its magnitude of angular velocity. Clear? So centripetal acceleration only enables the body to change its direction of motion continuously without changing the magnitude of angular velocity. Understood? So in the case of uniform circular motion, tangential acceleration is absent. Only the body possesses centripetal acceleration. So the body possesses only radial or centripetal acceleration. You can write it like this. Or this is the radial acceleration or centripetal acceleration, which is omega vector cross v vector. Clear, students? Now, as I have told you, centripetal acceleration, it always acts along the radius towards the center. That is the reason why centripetal acceleration is also known as radial acceleration. It makes the body to move along a circular path. Whenever a body is moving along a circular path, then it must be having centripetal acceleration. So it do not produce any change in the magnitude of its angular velocity. It only results in the continuous change in its direction of motion. And whenever the direction of motion of the body changes continuously, then the body must be following a circular path. Because while following a circular path, the direction of motion of the body changes continuously. Right? So, let us concentrate on its direction now. As I have stated, it always acts in the radially inward direction. So, let me convince you with the help of this diagram. Suppose the body is moving in the anti-clockwise direction. Right? At this instant, the velocity vector would be like this. It will be given by drawing a tangent. This is the velocity vector. At this point, omega vector, you are aware, it's along the axis and in the upward direction in case the body is moving in the anti-clockwise direction. So let's draw a parallel vector over here. So this is the direction of omega vector. Along the axis and in the upward direction. So these two are perpendicular. So here, it's omega vector cross v vector. It should be, angle should be oriented like this. Body is moving in the anti-clockwise. So here velocity vector would be given by drawing a tangent and omega vector is like this. So if we apply this rule, so the angle would be like this, omega vector cross v vector. So the thumb will point along the radius towards the center. So basically, this must be the direction of radial or centripetal acceleration. All are mutually perpendicular to each other. All the three are mutually perpendicular to each other. Clear, students? Make use of the properties of the vector product so as to obtain the direction of this centripetal acceleration. So make use of right hand thumb rule. So angle is to be oriented from omega vector to v vector, like this, omega vector to v vector. The finger should curl along the direction of the orientation of the angle. So the thumb will point along the radius towards the center. So that verifies centripetal acceleration is known as radial acceleration. It is because this acceleration always acts along the radius towards the center of the circular path. Right? So this is about centripetal acceleration. Now, since omega vector is perpendicular to v vector, it's pretty evident from the diagram. Therefore, centripetal or radial acceleration is equal to, this is the cross product, magnitude of angular velocity, magnitude of linear velocity, and the sine of the angle between them, which is 90. So it is omega v. Also, students, we are aware v is equal to omega r, or angular velocity may be written as v by r, isn't it? So substitute this value. So v square divided by r. So this is the magnitude of centripetal or radial acceleration. Clear, students? This is the magnitude of the centripetal acceleration. And why it is known as radial acceleration? Because it always acts along the radius. Okay, that's the case of uniform circular motion. Now consider the other case. For non-uniform circular motion. For non-uniform circular motion. In the case of non-uniform circular motion, students, the body not only changes its direction of motion continuously, but it changes its magnitude of angular velocity as well, continuously. Right? So basically, what's the role of centripetal acceleration or radial acceleration? It tends to make the body change its direction of motion continuously. And what's the role of tangential acceleration? It makes the body to change the magnitude of its angular velocity. Right? So in the case of non-uniform circular motion, angular velocity is varying. That is, it changes. It is not constant. So in that case, tangential acceleration also acts, and it is given by alpha vector cross r vector. This is the tangential acceleration, and as the term suggests, this acceleration acts along the tangent, right? So let's try to get the direction of this. Let me verify that this acts along the tangent. So again, let me concentrate on the same diagram. We have assumed that the body to be moving along a circular path in the anti-clockwise direction like this. The body is moving in the anti-clockwise direction. This is center, suppose. This is the radius. This is r vector. Right? This is r vector. And alpha vector, as I told you students, in case the body is moving in the anti-clockwise direction, then infinitesimally small angular displacement, angular velocity, angular acceleration, all are directed along the axis and in the upward direction, right? Along the axis in the upward direction. I am drawing a parallel vector over here, or equal vector over here. This represents alpha. Right? Now, alpha cross r. So it will be like this, alpha cross r. Like this. So this is r vector, increasing direction radius vector. So look, the angle is to be oriented from alpha to r. So using right hand thumb rule, my fingers must curl along the direction of orientation of the angle. So thumb is pointing tangentially. So this must be the tangential acceleration. All are mutually perpendicular to each other. They all are perpendicular to each other. So alpha is the angular acceleration, which is along the axis. This is the radius vector, increasing direction, and AT, that is the tangential acceleration, acts along the tangent, right? At this point, it is given by drawing a tangent at that particular point. And what's the contribution of this tangential acceleration? As I have told you, students, it enables the body to change the magnitude of its angular velocity continuously. It doesn't produce any change in the direction of motion of the body. It results only in the change in the magnitude of angular velocity of the body, right? So, in the case of non-uniform circular motion, the body possesses both centripetal acceleration as well as tangential acceleration. Centripetal acceleration makes the body to move along a circular path, and tangential acceleration makes the body to change the magnitude of its angular velocity continuously, right? So, for non-uniform circular motion, this is the tangential acceleration, and centripetal acceleration we are already aware. It is given by tangential acceleration, centripetal acceleration. It is given by omega vector cross v vector. So, it possesses both these accelerations, right? So, in this case, what will be the net acceleration? Let's draw this 2D diagram. Suppose the body is moving in the anti-clockwise direction like this. This is the center O. This is the radius. Now look, centripetal acceleration, as stated, it is also known as the radial acceleration. It always acts along the radius towards the center. So this is the centripetal acceleration. Tangential acceleration, just now we have discussed, it acts along the tangent. This is the tangential acceleration. So if the body is over here, it will be under the action of these two accelerations which are perpendicular to each other. So its resultant can be found by using parallelogram law of vector addition, isn't it? So its resultant would be this one. This is A net. So A net, it is equal to the vector sum of the centripetal or the radial acceleration and the tangential acceleration. This is in vector form. So since these two vectors are perpendicular to each other, therefore what would be the magnitude of the resultant acceleration? It will be definitely given by square root of AC square plus AT square. So this is the formula for the magnitude of the resultant acceleration of the body executing non-uniform circular motion, right? In case of uniform circular motion, AT is 0. So net acceleration will be equal to the centripetal acceleration. And also students, regarding the angle, suppose this angle is theta. It is the angle theta which the resultant acceleration makes with the tangential acceleration. So if you consider this particular triangle, this is a right angle triangle, consider tan theta. It will be perpendicular by base. So it is AC. In a parallelogram, opposite sides are equal. So tan theta would be AC vector divided by AT vector. So that will give us the direction of the resultant acceleration. So theta would be tan inverse AC vector divided by AT vector. So students, this is the expression which gives the direction of the resultant acceleration. Theta is the angle which the resultant acceleration makes with the tangential acceleration, right? Okay students, now let us discuss alternative method to find out the expression for the centripetal acceleration. So this is the alternative method to find out the expression for the centripetal acceleration. Expression for centripetal acceleration. Right? I'll be making use of calculus method. So suppose students, this is the case which we have considered. This is the center, this is the x-axis, and this is the y-axis. Right students? Okay. This is any arbitrary point P. This is the position vector. And let us consider this position vector makes an angle theta with the x-axis. Let its coordinates be x and y. So if you drop a perpendicular from here, suppose this is Q. So OQ, let us consider it to be x, and PQ, it will be equal to y. Right? In the vector form students, we are aware I cap represents the direction along x-axis, while j cap, it's a unit vector, represents the direction along y-axis. In the vector form students, position vector r vector will be written as xi cap plus yj cap. Put this as equation 1. Also, in this right angle triangle, if you consider cos theta, it will be base over hypotenuse. So x would be equal to r cos theta, isn't it? Similarly, if you consider sin theta, it will be perpendicular by hypotenuse, that is y by r, which implies that y would be equal to r sin theta. Put this as equation 3. Now what to do is, we simply substitute the value of x and y from equation 2 and 3 in equation 1. So what we obtain is r vector, it may be written as, in place of x you can write r cos theta I cap plus, in place of y you can write r sin theta j cap. Now our main objective is to find out the expression for the centripetal acceleration. And here we have considered the body to be moving in circular path in the anti-clockwise direction with constant angular speed, right? So we are discussing uniform circular motion. So here the body is assumed to be moving with constant angular speed, right students? Okay. What about the linear velocity then? It is given by differentiation of displacement with respect to time. So let's solve it. So it will be d by dt of this entire term. It is r cos theta I cap plus r sin theta j cap. Right? We can easily evaluate it. R actually can be taken as common, and then we can make use of the formulas for differentiation. Differentiation of sin theta is cos theta, while the differentiation of cos theta is minus sin theta, right? So what we get is R can be taken as common. So it is d by dt. So cos theta. Theta students, it's equal to omega t. Omega is the angular speed, it is equal to theta by t, isn't it? Omega is the angular displacement divided by time. Suppose this is at t equals to 0 and this is at t equals to t. So in time t, the body has covered an angular displacement of theta with angular speed omega, which is constant. So theta would be equal to omega t. So here we can write r can be taken as common. Over here we can write cos, in place of theta we can write omega t I cap plus r has already been taken as common. In place of theta write omega t, and this is j cap. Right? Now here the differentiation of cos theta is minus sin theta. So here what we get is minus, and this is omega, minus cos sin omega t multiplied by differentiation of omega t. So omega will come out as it is constant. So we'll get minus omega sin omega t I cap. The differentiation of sin omega t is cos omega t multiplied by differentiation of omega t, and that will give us plus omega cos omega t j cap, right? So omega being constant, it can be taken outside, minus omega r. So we can write here as sin omega t I cap, minus has been taken as common. So over here we get cos omega t j cap. This is the expression for the linear velocity. Now how to get the expression for the acceleration then? So acceleration students, it is equal to differentiation of velocity with respect to time. What we can do is, once again we have to differentiate this with respect to time, and that will give us acceleration. So minus omega r d by dt, and substitute this value of v over here. So minus omega has already been taken as common. So it is sin omega t I cap minus cos omega t j cap. Okay, let's solve it. Differentiation of sine, I have told you, differentiation of sine theta is cos theta. Differentiation of sine omega t is omega cos omega t, right? So it will be omega cos omega t. This is the case of uniform circular motion, students, remember, where body possesses uniform angular speed. Differentiation of cos theta is minus sine theta. So here it is cos omega t. So it will be minus omega sine omega t. Minus minus, it will become plus, and then omega sine omega t j cap, right? So omega can be taken as common, minus omega square r cos omega t is theta. Omega has already been taken as common, sin omega t can be written as theta, right? Now concentrate on this particular thing. R cos theta I cap plus R sin theta j cap is equal to R vector. Therefore, acceleration is equal to minus omega square, and this is r vector. R cos theta, look, r cos theta I cap plus r sin theta j cap. It can be written as r vector. So this is the relationship between the centripetal acceleration and the radius and the angular velocity. So let us discuss this statement. Centripetal acceleration is minus omega square r vector. Now look, students. This negative sign suggests that the direction of centripetal acceleration is opposite to which the radius vector increases, right? Now, what is the direction of radius vector? It's along the positive x direction. This is the direction of increase of r vector, right? So, what will be the direction of a vector then? It will be the opposite of the direction along which r vector increases. This is the direction of r vector. So, negative of r vector means acceleration will be directed along this direction. At any point during the circular motion, the centripetal acceleration will be always directed along the radius towards the center of the circular path. So this negative sign is suggestive of the fact that the direction of centripetal acceleration is opposite to that of the radius of the position vector. This is the position vector actually. So position vector is always directed away from the origin. So this being negative, so centripetal acceleration is always directed towards the origin. That is towards the center of the circular path which the body follows, right? So in magnitude, it is omega square r. And since we are aware, students, v is equal to omega r, or omega may be written as v by r, isn't it? Therefore, what we get is v by r whole square into r. So that will give us v square by r. So the centripetal acceleration in terms of velocity is v square divided by r. So this is the formula, or rather the expression for the centripetal acceleration. Actually, it can further be changed in terms of the linear frequency as well, right? So that also we can easily do. Look, A is equal to v square by r, right? Now we are aware v is equal to omega r, so it can be written as omega square r as well. Now we are aware omega angular speed, it is 2 pi by capital T. In time capital T, which is the time period, the body will complete one revolution. During that time it will cover 2 pi radian. It will have an angular displacement of 360 degrees, which is equivalent to 2 pi radian. So omega is 2 pi by T. So centripetal acceleration would be 2 pi by T whole square into r. So that will give us 4 pi square divided by T square into r. Now we are aware, student, linear frequency is reciprocal of time period, isn't it? We all are aware of it. This is linear frequency, right? So what we get is 1 by T square would be nu square. So centripetal acceleration is 4 pi square nu square r. This is the expression for centripetal acceleration in terms of the linear frequency, right? So what about centripetal force then? This is centripetal force. Force, you are aware, as per Newton's second law, it is mass into acceleration. So what we get is m a is v square by r. So F equals to mv square by r. That gives the expression for the centripetal acceleration, centripetal force. So centripetal force may also be written as m multiplied by a. You can substitute this value of a, that is 4 pi square nu square r. So this is another expression for the centripetal force. So students, I hope you have understood each and every concept. These are some very important concepts which we'll be doing in the later section as well, in the unit of rotational motion, right? So we have discussed all these topics in detail. So do practice all these articles and do try to remember all the formulas along with the direction of each and every vector which we have studied, right? So join me in my next lecture then. Till then, do take very good care of yourself and be happy always. Thank you.